for what it is worth, I think it's a good thing to just look at the impact computing is having on our lives across the board. So let's see, development of computers, right? So let's take a peek at the top right here. These are units you hear about every now and then. So I wanted to take a moment and just remind you of what these units really mean. So kilo is 10 to the power of 3, mega is 10 to the power of 6, and on and on and on. And where we are right here is we are in this area right here. And this is where we deal with quadrillions of flops. So what is flops? Floating point operations per second. So these computers, like, you can look at NVIDIA GPU or Intel GPU or Intel CPU or so on and so forth. Um, they're capable of performing large number of operations per second. Floating point operations are really a testimonial to scientific prowess of a computing device. So when we talk about, petaflops and exaflops, we're talking about quadrillions of operations per second. So that's the enormity of stuff that happens in one blink of an eye, right? And so this is where we are today. And I'm just going to draw your attention to where we started when we, came up with computers, and then where we are today. So let's kind of take an accelerated walk through history. So here, this is the ENIAC, I think first one. And here you can see a bunch of these wires. So the idea was that you pull the wires and you plug them into their respective sockets. And when all of these things were plugged properly, then you'd press a button, and then that would make one compute. So the one computation or exercise of a line of program was done by arranging all of these different wires in the different slots, and that was what programming was like. And obviously, it was done by human beings. Then here was a mini computer. So fast forward, like, a couple of decades. Then we had the Commodore personal computer. This is the first kind of example of a personal computing device. Not as compact as a laptop, or say this is a desktop right here. So let's take a look at it again. Actually, I kind of like this look more. And I can tell you that, I'm old enough to say that, yeah, this is when I first got introduced to computers in this generation. And then way later, we had these desktops. I think this is pretty much what a modern one looks like, except that we no longer have towers, at least, unless it's a gaming device. Most of the time, you just have your computes built into the back of the screen. And so here's a laptop, and then a bunch of personal devices. And then if that's not enough, then you got computing device in practically everything. And then, no story about computers over unless we talk about these massive, massive data centers that are performing exaflops of operations. So this is where this table is very handy, because all this stuff with weather prediction and earthquakes, forecasting earthquakes, for example, looking into the universe, um, discovery for medicines, vaccines, a lot of that stuff requires amazing amount of computation. So things that were never possible before, just even 10 years before, we are able to do them today because, and of course, I shouldn't miss this whole conversation about AI, right? I mean, if you look at any of the large language models, the reason they exist is because the training is done on billions and billions of pieces of data and compute. So, and that to be able to do that in a decent amount of time requires such processing power. So computers have come a long way in 70 odd years. Well, communication is not left behind either, right? So this one is a little dated, but I think it serves the purpose of communicating the growth. So 5.3 plus billion, this is back like a couple of years back. Now we are about 5.45 billion users. And so that's about 66 point some percent of world's population. So yeah, I mean, that's a lot, right? 2/3 of the population uses internet. And again, I mean, when you hear your faculty members like myself speak, many of us, we've been around for a long time. And we can say, yeah, I was there. Like for myself, I had started teaching when internet came into what you can say, not even mainstream, just become available to people. So yeah, it's a amazing amount of growth in communication. And then along with that, computes, along with computes, which you saw a couple of slides back, and along with internet, there is tremendous number of usage models that are promoting the growth of data. And so just from, I started at Texas A&M here, around here, after I spent a couple of decades building computers. I joined A&M here, and you can see on the relative scale, because this is zettabytes, which is trillion gigabytes, right? I mean, imagine amount of data. And so look at how explosive this thing has been, right? And we're here somewhere right now. So this is the forecast right here. And with the use of large language models and with machine learning, the exchange of data, processing as well as exchange is becoming hugely prolific. So we are in the middle of revolution, and it's changing the way we work and play, and anything else, right? I mean, you just saw pictures of the different forms of compute, and upcoming, I'll talk a little bit about how many of the things that are around us are changing as well. So I think disruptive is probably a good way to describe it, and congratulations to all of you that you are central to this revolution. I mean, every other field is being influenced by computer science. And so isn't it wonderful that you are at ground zero, affecting, or at least have the opportunity to affect what happens in the future? In case you're wondering, this one looks like a galaxy of sorts, but no, this is the internet, with the backbone and uh, all the end users, right? So it's just a small snapshot right here. So amazing. Yeah. So, well, age of information. Really, I mean, publishing is just has so many diverse forms. You have what you're seeing here is web pages, then news, academic articles, video, and then streaming content, right? So whole bunch of medium of information. When it comes to publishing and media, what you see on the left side here is a traditional newspaper and television, but then you got bloggers and streamers, right? So a lot of that is getting disrupted. Here, digital editing, we are very familiar with being able to, use word processors and edit image and so on. But then you can also there's many different ways of manipulating information. So here you look at this picture and it looks pretty real, right? I mean, you have the jet going near a mountainous region, but you can easily have created this in studio with a jet and then some background that is superimposed in the back. So here, bunch of missiles firing, and then there's plumes of smoke. But if you look at some of this stuff closely as to where things are going and where the smoke is coming, actual pictures on the right. And so, there was another one that was being fired here, but the image was created by just, copying and pasting. Deep fake. So here, Forrest Gump, Tom Hanks inserted into video with JFK. So there's a bunch of examples. Here, President Trump And then you have an artist who portrays him on a popular show. And then when you superimpose, you can create a deep fake, which looks like the president, but it's actually a deep fake. And here, Senator Warren, and again portrayed on SNL by Kate McKinnon, and you can see that a deep fake was created for Senator Warren as well. So personal interaction, well, good old days on the left. Then all this stuff right here. Now, something like this is not a surprise. Disrupting retail, here is full malls. I remember the 80s and the 90s fun days, right? In a way. And then now we can buy online. And so the malls are ghost towns at times. Transportation, taxis, yellow cabs, and so on. Now, with the gig economy, you can call an Uber. And then transportation, automation, that's driving things. And so, yeah, Tesla, taxis, there's all kinds of changes. Um, Organization of information. So that's different ways. And then you look at the future, of course, quantum computers are in the offing. And we're looking at 6G right now. 5G is very much the norm, and then looking ahead to 6G. Internet of everything means that everything is going to be connected. In many ways, it is connected. So you can see why it's just taken off like wildfire. Robot cooking, and then intelligent buildings, all sorts of connectivity in a building, cars, all sorts of image recognition, recommender systems. This is cybersecurity, maps, health, AI in healthcare, all of this good stuff, right? So the reason I'm showing this is just to make sure that we know our place in history, right? It's in history in the making. Our place is really at ground zero of revolution. We have the opportunity to impact the world in many, many different ways, for good or for bad. I've crossed out the bad because we can only do good. So the CS program is really, the courses you take, the projects you do, all of this is synergized with the objective of helping you learn how to make the following things happen. So first, how do you think computationally, right? I mean, that's all behind the art of programming, um, and testing, how to analyze, how to design, how to develop, right? All of these things are something that are going to be highlighted in many different forms by the course structure that you are going to take in computer science. Let's talk a little bit about jobs. The salaries and opportunities can vary wildly, right, across geography, industry you work in, who you work for, the job you do, background, and general economic conditions. So here's an example, a recent one, right, from April. You can see that this is from labor statistics, that there are a bunch of computer IT occupations, the median pay is pretty high, right? You can see some are master's degree, some are bachelor's degree, but the idea is generally in the neighborhood of 100,000 and plus per year, and it goes up from there. This is some survey that our Career Center does from spring 2024 grads, this is an input. And so we look at computer science right here and computing, and you can see here median, and this is master's, this is doctorate. Interesting, the reason doctorate is low, I think it is probably because the survey was done for folks who went into academia, right? But in industry, the salaries are much higher. Like this one is really more like what you'd get paid out of school with a doctoral degree in industry. Yeah, bachelor's 90,000. So, TAMU grads are making what I showed you in the previous slide. So it's pretty competitive. Just tons and tons of companies. Career centers coming up. Career fair is coming up very soon. And so you'll get to see a bunch of these companies. Well, unemployment rate globally 4.3%, but computer occupations is pretty good, 2.8%. And when you look at 100 best jobs, 3 or 4 of these are related to our field. So again, a great thing. And that's pretty much it for the conversation on the course introduction. So let me just recall really quick what I want you to do. For this course, we will meet weekly Tuesdays, okay? So no Thursdays. Thursdays only an exception, and I'll tell you way in advance if we're meeting Thursday. Otherwise, the default is every Tuesday. We will meet over Zoom. The link is in student resources and the Zoom logistics. And please, please, please do take care of these 2 following steps. First one is make sure that you have authenticated yourself to tamu.zoom.us. And that's because we need your TamuNet ID. And the second step is go to your profile and then in profile, confirm that your full name, first and last name show up in the profile, okay? We need these 2 things to track your attendance.